Today is going to be a pretty exciting day. I'm gonna finish the robotic arm I've been working on for the past 7 videos. Here I got the electronics, the pneumatics and the controller. The old prototype of the robotic arm has been disassembled. I get these 4 servo motors. I'm gonna have to calibrate them before I put them into the robotic arm. Here I got the 3D printed parts. And finally here I got the latest version of my soft robotic gripper. So first I'm going to prepare all the parts, assemble the robotic arm and then test this gripper out and hopefully pour some energy drinks into a glass. I got ESP32 with a calibration code for these motors. I actually used this for my first video of the robot dog series. This code is going to set the servo motors to their middle position. You can see that the arm isn't parallel with the servo, so I'm going to change that. You can see that these servos aren't exactly aligned. I can fix this in my code. This servo, I wasn't able to detach the servo arm because the bolts are fucked. I'm gonna set offset of this servo for 90 degrees. Now I'm going to prepare these 3D printed parts. What I'm gonna do is get rid of the stringing. That's a pretty poor quality. I'm going to use this hot air gun and I'm also gonna add in some heat set inserts. The assembly is actually quite complicated. It's been a month since I last touched this project because I was busy making the AI stuff for my school. So I'm just going to start from the base, attach these legs, use the heatset inserts and build my way up to the gripper. This is going to be bigger than I thought, which is nice. This wobbles too much. I might reprint this part later. This is quite stiff, by the way. This bottom part is horrible. But if I hold it still, this top part is quite good. This is a really complicated part I made. It clamps the carbon fiber tube like this. And then it has this wedge and it gets connected like that. And this part is completely useless. It's just to make it look better. Now I'm gonna connect the gripper. It's not going to be connected electrically or pneumatically, just mechanically for the effect. I want to see how cool it looks. And it looks pretty cool. It's not strong enough to hold its weight. Assembling this took an hour and a half. I feel 5 hours older. This looks pretty cool, but I need to make some minor changes before I can plug in the electronics and the pneumatics. If you look at this joint, in CAD it lined up perfectly, but here it stops. You can force it over, but it's not ideal. So I'm going to snip off this corner. And another thing, this arm is super heavy. It can't even support its own weight. It just flops over. So I added this. This is 800 grams of force. I originally wanted to add some springs, but some of you actually recommended to buy this door something. It just provides 800 grams of pull force, and it's perfect for my need, so I'm going to attach that to the arm somehow. Nice. You know what? I don't really want to attach this stuff, so I'm going to plug in the electronics first because I want to see this thing move. I just uploaded the changed code, so I changed the link lengths, and that's everything, I think. By the way, it's very nice that I added this hole for coding the Arduino, because now I don't even have to open this electronics box. I can just plug in the cable and code it that way. So I'm going to take this, plug in the servo motors, turn it on, and hope it doesn't smack me in the face. These PCBs, I made them in KiCad. It wasn't hard at all, and then I ordered them with my sponsor PCBWay. So if you're making projects like these, you don't want to use just breadboard, you want something that's professional. And with PCBWay you can get an instant quote. So you just type in the dimensions, quantity and number of layers. You can also choose the thickness of your PCBs, and I usually switch the color to black because it looks cool. Then you just upload the Gerbil files and you can actually track the manufacturing progress. Also, if you click the link in the description, you will get a $5 discount for your first order. I need to see which motor is which, because these cables aren't numbered. Fuck, I don't remember how I numbered them, but I assume... Yeah, servo 0 is the gripper, I know that. The base rotation is gonna be servo 1. This is gonna be servo 2 and this servo 3, I think. So I think this one is the servo. So let's take that cable and just plug it in. This shouldn't cause any harm, I think. Fuck. So I changed this minus 90 to plus 90. We're gonna see if this helps. I think I forgot to calibrate this servo. I just uploaded the code for calibrating the servo motors, and I made sure that all of them are at 0 degrees. As you can see, this is not a right angle at all, it points down. This should be completely horizontal. This is because the offset of the servos. So when I attach the servo arm, it's never exactly 90 degrees or 190 degrees, it's always 3 degrees off or something. I'm going to calibrate it later, but I want to see this thing move, so I'm going to fix the inverse kinematics first. Very nice. Finally. I assume that this servo motor's natural position is just to be straight up, but the way I calculated the inverse kinematics, it was like this. So I just added 90 degrees to this motor and now it works. So this point should be 250 millimeters that way and that way from the base, which looks quite correct. Now I'm just going to sort out the servo offsets. I just want to make sure that these servos, when I set them to be at 0 degrees, they are exactly at 0. At these lengths it's gonna show. Of course I'm going to try to move this arm. Nice. I think it's about square now. This one was 6 degrees off and these two. So I just changed the calibration like this. And now I'm going to put these offset into the main code. I rewrote the code a bit, I just made it more easy to read. So here I set the angle offset, these 90 degrees, that's from how I place the servo, and this little 6 degrees offsets are from the fact that the servo arm isn't exactly straight. Then when I calculate the inverse kinematics, I add the angle offsets, I saturate the angles, and then I set the angles. I think this code structure is better than what I had previously. The inverse kinematics seems to work out pretty well. Oh my god. This is so cool. This is the best part about engineering, when it's starting to work out, when you finally assemble the thing and you can start playing with it. When you put the arm down, you can see that it can't reach all the way down there. Instead of going straight down, it goes to the left a bit. And I think this is because it's outside the workspace. I'm gonna check with the simulation later. But other than that, it works pretty well. Yeah, you can see that the workspace doesn't quite reach into this area, so that's probably what's happening. I think I'm going to add this cable management thing, so it looks better, because I can't look at these ugly servo cables. If you turn off the arm, it goes to sleep. So I'm going to reprint this part, because that's why it wobbles so much. This is just from the backlash of this servo motor, and if I move it sideways like this, this is from the sturdiness of the base, so it's about the same. I think I'm happy with this. Yeah, now it doesn't shake. Before, when I had it just like this, it was shaking all the time. Now it's much better. So there's gonna be a problem that these dew point connectors, they just keep falling out. I think I'm going to just use zip ties for that, if I have any. And then for the cable management, I think it would be nice if the cable went from the back side, like this, to the bottom. I forgot about this, but when I designed the arm, I meant for the cables to go in this part of the arm. So I'm going to unscrew this. The arm would work perfectly fine like this. So this just goes to show that this single carbon fiber tube is stronger, lighter, and easier to manage that, like parts like this. That's why I'm gonna use them for my robotic dog. Fuck, this is gonna be super hard to pull through this cable. I need to test which cable is which. Okay, so these two cables are wrongly connected. This is not gonna be pretty, but I'm gonna just duct tape this connection and put it inside this link. This is not my proudest engineering solution. It's not really what I envisioned. I guess it's better than before. I want to screw the pneumatics box and the robotic arm together because it's kind of annoying to have to pick them up both separately. And I just realized pretty bad design. So if I want to bolt this together, I can't really screw it in because this pressure sensor prevents me from doing so. If I wanted to screw it from this side, I would have to take this whole arm off, which would take a long time. So this is kind of shitty design. So this is a pretty shitty design, but I don't think that most people would design something like this on the first try and have all of the connection perfect. Maybe if I spent a little bit more time on the CAD, I would have noticed this. I just wanted to share this moment because I make mistakes like this all the time. And by the way, it looks so cool. If you open the pneumatics box, it's very nice. This is either gonna be pretty smart or pretty stupid. Perfect. It holds much better than I thought. This is all one piece. I thought about how I was gonna attach this pulley system. The simplest thing would be to attach it like this. This sucks because it decreases the workspace a bit, but it's also super simple and I have no way of attaching it differently. I thought about adding it here, but this leg couldn't be folded upwards, so I'm just gonna go with the simplest way. I can already feel the difference. It's huge. Now the workspace is gonna be decreased. Yeah, that's quite significant. If the workspace is gonna become a problem, I'm gonna change that, I guess. I thought about adding it here, then it wouldn't decrease the workspace, but it would decrease the torque offset because it's not pulling straight like this, it's at an angle. If I put 500 grams here, that's a lot of weight, plus the arm is super long. I need it to be able to lift 500 grams because I'm going to pour energy drinks with it. I need all the help I can get. So I'm gonna go with this option. This left button pressurizes the system, and this right one releases the air through solenoid. This is the cherry on top. This is the best pneumatic gripper I've made. I let it solidify for about a day from both sides. I hope it's gonna work, otherwise that would be pretty bad. It leaks a bit, but I'm gonna try it anyway. Okay, this is quite bad. I'm gonna try to seal this gripper up and hopefully it's gonna work. Other than that, I think it looks pretty fucking sick. The design is so cool. I mean, you got this tension cable, which reduces the torque of this motor. And this tube, I like the fact that the cables and the tube ran inside the carbon fiber tube and inside this plastic. It's very nice. This is the moment you've been waiting for. The arm is finished, hopefully. Everything works electronics wise, inverse kinematics perfect, the mechanics are great. Pneumatics seem to be working too. So I'm going to do a first test, which is going to be lifting this up and dumping these pills into this bowl. After that, we are going to move to the main thing, which will be pouring this energy drink into a glass. Okay, second try. Okay, that kind of worked. Okay, now it should be fine. I just wrapped it around from the bottom. The problem is that there are still some leaks, so when I close the gripper, I try to use the controls to move it to the bowl, but the gripper is constantly losing air, so it's just slowly opening, and I have to keep pressing this button, and just not ideal. So I'm going to quickly code up some regulators, so it's going to use the pressure sensor, and if the pressure gets lower, it's gonna just pump more air in. I updated the code and it worked first try. This doesn't happen often. So when I turn this on, it's gonna be quite loud. The pressure is set with this potentiometer and I set it to be pretty low. And if I increase it, it's gonna close up more. I also left in the button controls. If I hold the button, I can override it and it's gonna manually set the pressure higher. And when I release the button, it's gonna go back to the automatic control. And the same with solenoid, I can set the pressure to be at the middle and I can just release it manually if I want to. But I have to say, it's extremely annoying. It's so loud, holy shit. That's the solenoid just clicking on and off. I think this is called like 2 threshold regulator. So I get a desired pressure, lower and upper bound. If the pressure is in between the lower and upper bound, it does nothing. Once the pressure gets higher than the upper bound, it's gonna turn off the pump and turn on the solenoid, so it's gonna vent the air. When it gets to the lower bound, it's gonna turn off the solenoid and it's gonna turn on the pump. I've placed these thresholds pretty close to each other, so that's why it's constantly clicking on and off. Here I measure the potentiometer value and I set the desired pressure according to the potentiometer. I check if the measured pressure from the pressure sensor is higher or lower than the desired pressure. If it's higher than the desired pressure, I turn on the solenoid and turn on the pump. If it's lower than the desired pressure, I do the opposite. Also, I check if I have these buttons pressed. If I have the left button pressed, I want the pump to turn on regardless of the pressure sensor value. So this only works if the button is off. The same for the solenoid. That way I can have this regulator working. If I want to pump the air in the controller is gonna turn off and it's gonna pump more air in. If you measure the pressure, you're gonna get shitty readings. So the pressure value might be this, but the sensor will give you this plot. So I'm using filter to go from this red line to something smoother. Otherwise, all of these spikes, they could mess with the controller. Once I give it the bottle, it works pretty well, but it's terrible at actually gripping it. I wasn't recording this, but the gripper just blew up. This sucks a lot. I've spent so much time trying to make this gripper work, but I think I was just optimizing a terrible design. Even if I remake this, I don't think it's gonna work. It's not reliable at all. So much work and the gripper is still trash. This is kind of sad. These are just a few prototypes. I threw most of them out. And this was probably my best gripper ever and it just blew up. This fucking sucks. The whole reason I built this robotic arm, by the way, was for the gripper, because I thought it would be cool to use the gripper somehow, so that's why I built this entire arm. And now that the gripper doesn't work, it feels like a waste of time, to be honest. You know what? This fucking sucks, but the arm is quite good. The electronics work, the pneumatics work, even the regulator for the pressure works. Everything works, it's just that the gripper is trash. So I might as well just make a new gripper. Not this one. I'm gonna go in a different way and try to make a completely different design. I actually saw some pretty cool designs on YouTube that instead of being just straight, they have these capsules and gaps in between them. And when the capsules inflate, it just bends the arm. These seem to work much better. So I might go in that direction. Since this is the technical channel, I want to talk a bit about why this gripper failed and why I even decided to go with this terrible choice. So when I first started making these grippers, I very quickly realized that the thinner they are, the better. The thicker the gripper is, the worse it bends. So I went from this to slightly thinner gripper, which worked better. And finally I made this super thin gripper, which worked quite well. And I was actually able to grab a spray paint with it. Another thing I realized is that they were awful for gripping anything that isn't spherical or cylindrical. It's not a general gripper. So when I made this gripper, I was pretty deep in this project. I didn't want to throw all of that time that went into making this and start from the ground, even though that's probably what I should have done. So I decided I'm just gonna not use it as a general gripper, but that I'm going to grip energy drinks. Because to be honest, I don't need a robotic arm, I just do it for fun. And I think it would be very cool if I would be able to grab an energy drink and pour it into a glass with this gripper. That's how I ended up here. I kept making these grippers. This one was kind of decent, but they all suffer from the same issue. You need to bend this about 180 degrees, and it just puts a lot of strain on this material, and it's going into the plastic region. Yeah, for example, this one didn't break, but you can see that this is plastic deformation, it's permanent, and that's because it was strained too much. I think this is a fundamental issue, and you probably can't get around this. Maybe if you made this extremely thin, I think it's not great. So what I'm going to do next is check YouTube. I'm gonna go through different gripper designs and pick the best one, and maybe I will even make a better gripper that will be more general, but I still want to pick up the energy drink and pour it into glass, because that's my goal. So I think I'm going to go with something that has 2 fingers, and instead of having to bend 180 degrees, it will just go like this and have to bend only a little bit from each side, you know, like a human hand. So that's what I'm gonna do next. So maybe one more video, hopefully, and I will try to make a gripper that actually works. So thank you guys for watching. Hope you like this robotic arm, even though the gripper blew up again, and I'll see you soon.